Good morning. This is your science lesson video for Friday, May 15th. So make sure you have all those materials out and ready. Now, our standard we're still working on today is I understand the interdependence of ecosystems and cycles. And so as part of that understanding, you need to know how they work, which is the sequence of events. You need to understand what goes into the cycles and what comes out of the cycles. And then also be able to use the vocabulary effectively to describe those cycles, to compare and contrast them and look at which features are similar and which ones are different, and then to evaluate and analyze them. What happens if one part is taken out of the cycle, or what happens if something changes in the cycle? So today is our last video lesson. It's a little shorter lesson today because I want you to get started on your last project of the year. And your last project of the year is going to be creating your community garden. And there's only a few questions to answer, and the rest is going to be fun. You can either draw it or you can use your Google document. And I'll share a whole separate video going over that assignment with the rubric and everything. This is also your last ERQ question for week 7 and 8. There were 7 days worth of questions. Each day is worth 20 points. So, and they're listed through each day, but it's a total of 140 points. Remember, these are like your exit tickets. So we're going to start by watching the water cycle video. I forgot to put the link on here, but you can just go to BrainPop and type in water cycle. I also put the link on your Canvas, so that's there as well. If you're interested in learning a little bit more about the water cycle, you can watch the BrainPop video on water pollution. We're going to read the hydrologic cycle today. It is on ReadWorks, so you can either read with me, read it on your own, or read it using ReadWorks. And then there's also a really good simulation that you can go to on the NASA site that shows how the water cycle works in an animation. So that's an optional simulation as well. Hopefully by now you've been able to collect some plant data. We will definitely all post some other videos once mine starts sprouting and I collect data. And we'll also look at these in our Zoom meetings. And for some reason, we aren't able to collect data because the weather's been so cold and it takes longer for seeds to sprout when it's really cold out. That's okay. You'll still have your plants to grow over the summer and you can observe them over the summer. So these are going to be more for Friday and Monday. And then starting on Monday afternoon in Zoom, all we're going to do Monday, Tuesday is present several of our projects. There will be a short Elastic Ecosystems assessment, and I'll post that on Friday as well. It'll be less than 10 questions. All right, so here we go. The last few days we have learned about food webs, food chains, and the food pyramid. We've learned how there's 3 types of organisms: producers, consumers, and decomposers. And that as consumers, there's different types of consumers: herbivores, omnivores, carnivores, and also scavengers. And we learned how decomposers are important in the nitrogen cycle, which puts nitrogen in the air and in the soil, and how plants need nitrogen to grow. We learned about how plants and organisms work together to perform the carbon cycle, which creates oxygen, and how that carbon cycle is part of photosynthesis, which ends up creating energy and sugars in the plant that we need to grow. And so today we're working on the water cycle. Now this should be a review. I know we talked a little bit about the water cycle at the beginning of the year too, so I'm not going to spend too much time on today. But there are some key vocabulary words and some key concepts here that we want to think about. So our central question is, how is water and sunlight key to all the cycles? So if you haven't already guessed that this is one of our really big ideas, without sun and without water, none of the cycles would work. If we don't have water, we don't have the plants. We don't have plants, we don't have the food web. We don't have plants, we don't have the carbon cycle. We don't have plants, we don't have a nitrogen cycle. And then also, this is how water is recycled through the ecosystems. So we talked a little bit at the beginning about how the water that we drink is the same water the dinosaurs drank. It's just recycled for millions of years. It doesn't change. The earth doesn't produce water. It's either going to be in a cloud or in a river or in our bellies, but we don't actually produce any more water. It's just recycled. And then also that organisms are part of all these cycles. So if we took out organisms, we wouldn't be able to run even the water cycle. Organisms are part of this cycle as well. All right, so we're going to answer, you only have one ERQ question today because I do want you to start on your community garden project. So we're going to start. I see 4 text features. Let's see if you can name them real quick for me. This should go so fast now. We've done this so many times. Title, diagram, caption, oh, bullets, subtitle. And we have other subtitles on the back. And we have another caption here. Again, these are on the photos, can be seen better on ReadWorks. The text is from the U.S. National Oceanic and Atmospheric Administration. NOAA is what that's called. People call it NOAA because the abbreviation is spelled like that. And our word here is hydro, which means water, logic, hydrologic cycle. And this is just the fancy middle school term for water cycle. We have condensation, transpiration, evaporation, surface and runoff, snowmelt, runoff, and precipitation. All right, these are all of our keywords. And these are kind of your main vocabulary words to this unit as well. And I think most of these should be review, except for maybe transpiration. All right, we're going to see if there's any big words. There's lots of big words in this one, so we're going to do some pre-reading. Hydrologic, continuous, circulation, atmosphere, camera cut off again like it did before. All right, we hope we fixed everything. My camera seems to be having some issues, but hopefully we have our recording. Evaporation. And on our other side, transpiration, condensation, precipitation, and ooh, here's a really good word. We haven't had this one. Coalescence. Not coal essence, coalescence. Saturated. Remember the T sounds like ch. Saturated, not saturated. And I think that's pretty good. I think we're ready to go. Either press pause and go ahead and read on your own, or you're going to read with me or read on ReadWorks. All right, here we go. The hydrologic cycle involves the continuous circulation in the Earth's system. At its core, the water cycle is of the water from the ground to the atmosphere and back. Of the many processes involved in the hydrologic cycle, the most important are evaporation, transpiration, condensation, precipitation, runoff. Stop real quick and say these words a couple of times to make sure you have those deep in your brain. All right, we have a great definition of the water cycle. And this is definitely a key idea. So we're going to highlight is the motion of water from the ground to the atmosphere and back. All right. Evaporation is the change in a substance from a liquid to in meteorology, the substances we are concerned about the most is water. For evaporation to take place, the energy can come from any source, the sun, or objects on the earth, such as everyone has experienced evaporation personally. When the body heats up due to the air temperature or through the body secreting water onto the skin. I'm going to pause here. A great word I didn't get. Secreting. All right, so what is the definition of evaporation? When it goes from a liquid to a gas. And what is necessary for evaporation to happen? Energy, specifically some sort of heat. And what is the example of our bodies that participate in evaporation? Sweat. All right. The purpose is to cause the body to use its heat to evaporate the liquid, thereby removing heat and cooling the body. It is the same effect that can be seen when you step out of a shower or swimming pool. And we're going to pause there. Why do we sweat? It's the effect of our sweat. It evaporates the liquid, and then it cools us. So when you get sweat on your skin, when the water evaporates, it cools you down. The coolness you feel is from the removal of bodily heat to evaporate the water on your skin. Transpiration is the evaporation of water through, did you guess that word? Stomata. These are holes in the leaves. Stomata are small openings found on the underside of leaves that are connected to vascular plant. In most plants, transpiration is a passive process, largely controlled by the humidity of the atmosphere and the moisture content of the transpired water passing through a plant. Only 1% is used in the growth process of the plant. The remaining 99% is passed into the atmosphere. Do you remember what the growth process was of plants? What do we call it? Starts with a PH. Photosynthesis. All right, so we have a good definition of transpiration. Basically evaporation, but from the leaves of plants. I'm going to highlight leaves because that's where it happens. Condensation is whereby water in the atmosphere is changed into a liquid. In the atmosphere, condensation may appear as clouds or dew. Condensation is the process whereby water appears on the side of an uninsulated cold drink can or, all right, we're going to pause there. What's the definition of condensation? Water vapor is turned into liquid. Water vapor just means water in the air in a gas state. So we can't see it because we can't see a gas, but we can see it changing back into a liquid. When we see clouds, they're condensing. When we see fog, and then also when we see, your example from real life is when water appears on the side